These two PCs can't reach each other. The devices are connected, but the router links are still red. That's what we're fixing. Let's build it from the beginning. Start with one router, 2 switches and 4 PCs. Place 2 PCs on each side. These 2 PCs will be in our first network and these 2 will be in our second network. We'll use the router to connect the 2 networks. Now select a copper straight-through cable, connect each PC to its local switch. Then connect the first switch to the router's GigabitEthernet 0/0 interface. And connect the second switch to GigabitEthernet 0/1. Now look at the router links. They're still red. The cables are connected, but the router interfaces aren't active yet. And there's one important thing to understand before we configure them. A switch forwards traffic inside a local network. To move traffic between 2 different IP networks, you need routing. That's the router's job here. Open the router and go to the CLI. If Packet Tracer asks about the initial configuration dialog, enter no. Now type enable, configure terminal, interface Gigabit Ethernet 0/0, IP address 192.168.1.255.255.255.0, no shutdown. This gives the first router interface the IP address 192.168.1.1 with a /24 subnet mask, and no shutdown activates the interface. Now watch the link, there we go, red to green, our first router interface is up. Now we'll do the same thing for the second network, type exit, interface Gigabit Ethernet 0/1, IP address 192.168.2.1, 255.205.255.0, no shutdown. This interface gets 192.168.2.1 because the devices on this side will be in the 192.168.2.0 network. And now both router interfaces are up. One thing worth knowing here, we don't need a routing protocol. Both networks are directly connected to the router, so it already knows how to reach them. Let's save the configuration. Type end. Copy running config, startup config. Then press enter to confirm. Next, we need to give each PC an IP address. Open PC1, go to desktop and then IP configuration. For the IP address, enter 192.168.1.10. For the subnet mask, 255.255.255.0, and for the default gateway, 192.168.1.1. The default gateway is the router interface connected to this network. Now open PC2, we'll give this PC 192.168.1.2, the same subnet mask and the same default gateway. That's our first network configured. Now let's configure the PCs on the other side. PC3 gets 192.168.2.10 with the subnet mask 255.255.255.0 and the default gateway 192.168.2.1. PC4 gets 192.168.2.20 with the same subnet mask and the same default gateway. Now we have 2 separate IP networks connected by one router, but configuration isn't enough. Let's verify that it actually works. Select Add Simple PDU. First, we'll test the local connection. Successful. Now for the important test. We'll send traffic from PC1 in the 192.168.1.0 network to PC3 in the 192.168.2.0 network. And successful. The packet crossed the router and reached the other network. So let's quickly recap what we just built. We connected 4 PCs to 2 switches. We configured 2 router interfaces. We created 2 different IP networks. We assigned the correct default gateway to each PC. And finally, we verified communication between the 2 networks. Now try rebuilding this topology once without following the video. If you can configure it from memory and get a successful test, you understand the process instead of just copying the commands. If you're studying for the CCNA, take the free 15-question readiness check below. It's scored by exam domain and you don't need an account to start. Link below. Studying for the CCNA, there's a free readiness check linked below. Now back to the lab.